Welcome students. Last time we have seen how to prepare a mold so as to make a casting. Today I shall introduce you to pattern making. What is a pattern? As I have told you, the pattern is the most important tool that is used in the casting process. Now, without the pattern, we cannot make the casting. As an example, I will show you. This is one of the patterns, and the casting that was made is this. So, without this pattern, you cannot make the casting. This is the final product. This is the first tool that is used. This is used to prepare the mold. We have seen how we prepare the mold in sand. So this is the one that is used to prepare the mold. So once the mold is prepared in sand, then we pour in molten metal, and after it cools down, we get the casting. So with this understanding, we can define a pattern as the primary tool that is used in the casting process. It is used in preparing a mold in which, when molten metal is poured and solidified or cooled, we get a casting. So I hope the link between a pattern and the casting is understood. For making a pattern, we select a material depending on certain factors, or we select the pattern material depending on certain rules. Now, the first rule is depending on the quality of the casting. Now, what would you mean by quality? See the finish of this casting. It's smooth. Okay? So, if you want a smooth finish on the casting, and if you're not going to machine further, we can use wood? No. We will have to use metals, specifically aluminium or steel or brass. Okay? We can't use wood. Reason, even if we use wood, there are pores. So we do not want this pores to be opened up in the sand. So in order to get this clear and smooth finish like this is a casting. This is a casting. See the finish here. It is rough. It is rough. So, if you want a good finish, if you want a good quality of casting, we require the pattern to be of good material. Specifically, you can use any metals. Now, this metal will also be durable, or you can use it n number of times. Okay? So, if you make it of wood, probably, let's say you want to make 100 pieces of castings using one pattern for this month. In 3 months' time, you want to make another 500 castings of the same type. In another 6 months' time, you want to make more 500 pieces. So like this, if you want to continuously make molds, so you can make it of wood, but after a certain period of time, even this wood deteriorates and the edges break off like this. So, in order to have a good casting, that and the material of the pattern to be durable, we can make it of metals like brass, aluminium, steel, which will last longer. Okay, now, first was quality. Second is quantity. As I have said, I want to make 1,000 numbers. If I make it of wood, in course of time, you will see the edges peel off. So wood is not a good material for making many molds. So I will use metals. Now, if I want to make around 100, the quantum is only 100, then I can make of wood. But whereas if the quantum is more, let's say of 500, 1000 or 1500 castings, so then I will have to make it of metals or any good material that is durable. I can make it of Teflon or nylon. We have some plastics which are like Teflon and nylon. We can make it of that also. Okay, now the next is intricacy of casting. An intricacy of casting. What do I mean by intricacy? There are fine details. For example, you want to print or you want the certain thing, certain name to be embossed like this. So there you will require your pattern to be of good material and not porous like that of aluminium or steel or brass. So if you want the finest details, then you got to have good material. So that is intricacy of fine details of the casting. So if you want your casting to show all these details, you require a very good material for it. So if you want to change a certain design, then you will require your pattern also to change. So the shape of the pattern will change slightly depending on whatever shape you desire on your casting. So now, if the pattern has to be changed slightly, your material should be machinable or easy to machine. If it is not easy to machine, then you have to change the whole pattern. So that is not feasible. So in order to make it feasible and less expensive, our pattern should be such that you can machine it easily. So it is machinable, or you can remove certain material. The next is the number of castings to be produced, which I have already told you. Okay, so now the link between the pattern and the casting we have seen. So we have seen the difference between a pattern and a casting. So now, the pattern is the first material that is used, or the first tool that is used to prepare the mold. And this is the final casting. So now, we shall see the various materials used for making a pattern. Some of the materials that are used for making a pattern are wax, wood, aluminium, steel. It can be any steel, it can be stainless steel, it can be, but they should be machinable. You can't say high-speed steel or hardened steel. Now the hardened steel is difficult to machine, so that's why we make, because basically we want to make a molding sand. Okay? So now, these are some of the materials used for making a pattern. Now, we shall see the various patterns. In order to understand the various types of patterns, how are they given their names? They are given the names by the way they are used in preparing the mold. I have shown you how to prepare a mold from a single piece pattern the last time. Okay, now single piece. Why a single piece? Because we have the poke and the drag. We keep the drag down, inverted, with the ears facing upward. We keep it on a flat board, which we call the bottom board. We put this pattern will be in the center. Okay? And the sand on all the sides. Now, this is done in a single go. or a single setting. So that's why this is called a single piece pattern. Now, what happens in a split pattern? Let's take an example. Let's say this is a single piece, round. It's tapered on both the sides. Let's say I want to make a mold in this manner. Is this possible? No. Reason, without disturbing the mold, we cannot extract the pattern. So, that's the reason we split it into two. We split it so that one half or one part remains, it's not necessarily half, it can be parts. Some parts, sometimes it's not round like this, it might be oval or it might be half square and half round or something like that. So then, this is split into two. One part will be in the drag, the other part will be in the core. Both are joined together by means of dowel pins. We put pins inside so that they are locked, so that as we ram, this should not move. While we prepare the mold, this should not move. That's the reason we require dowels to lock the part in the drag with the part in the core. So, it is split. That's the reason we call it a two-piece or a split pattern. The next pattern is a matched plate pattern. Let's consider we have a plate. We have a plate and these two parts are fixed on the plate. Now, to prepare the mold, it's easy. This will not move. So, what we do is, we take the drag or we take any one of the flasks, we fill in sand, we invert it, we fill in sand on the other side. So, when we want to remove the plate in between, what we do is we just tap on the flask. The flask can be separated from both the sides, the coke as well as the drag. So when we have a plate in between on which the two parts are fixed or assembled on a plate, we call it matched plate pattern. Okay, after matched plate pattern, the next is a loose piece pattern. In a loose piece pattern, we have a small loose piece. Now, let's say we have something like this. A circular and a small step down. We can prepare the mold using a single pattern. Something like this. Let's say this was round and we have a small step down. Now, to that step, we have a small extension. What happens is, when we prepare this, sometimes there can be the sand shaken. So, in order to prevent this, we separate this part. It is not complete on the top, it is halfway. So it is not to the top, it is slightly below. It is not right to the top. This part, this small key, it is slightly below. As you can see here, it's slightly below. So now what happens? There will be sand on this. So when you remove it from the sand mold will shake. So to prevent this, we separate this part. And when we prepare the mold in sand, it will be a single piece pattern with a small extension. This small extension is loosely held in the sand. Since this is loosely held in the sand, we call it a loose piece pattern. So the difference between a loose piece pattern and a split pattern. Split pattern, one part is in the cope, the other part in the drag, in which they are separate. In this, both are in the drag. The loose piece as well as the main piece, main pattern. They are both in the drag. So, when both are in the drag, we call this a loose piece pattern. What's the difference between this and a single piece pattern? Loose piece and a single piece. Single piece, there is only one piece. In this, there is a small extra piece. So, the difference between a single piece and a loose piece pattern, a loose piece pattern is a single piece pattern with a small piece that is loosely held in the stem. A single piece is a single piece pattern. There is no loose piece. So that's the difference between a loose piece and a single piece. Split and match plate. You know the difference. Split and loose piece. I've just told you the difference. Now we shall go to the next part. Next type of pattern, which is called gated pattern. Let's say we have one molding box in which we have small patterns. They are interlinked by means of small passages. Okay? So these passages are interlinked so that when you pour the molten metal, just like if you see in a refrigerator or a fridge, you have your ice tray. So when you have if you pour water in one, it goes on filling. So there's a small gap in between one mold to the next mold. So that way it goes on filling. So there's a link between all the molds. So when there is a link between all the molds, as an example, this one. This casting, see there are many castings prepared, 1, 2, 3, 4 and 5. They are interlinked. This is called a gated pattern. So many patterns are interlinked and there was only one place from where you poured and rose. So that is called a gated pattern. Okay, the next pattern is a sweep pattern. Let's take, for example, something round. Just like if you have seen your fan motor at home, so the motor housing is round. So there, you do not need a physical pattern. What we can do is, we can cut a cardboard of that shape. Let's say, this is the shape of your mold. Okay? So let's say this is the mold that is to be prepared. So this type of mold in a circular manner, what we can do is, we can cut a cardboard with this shape. And a pivot at one end, and we can drag it, we can fill the drag with sand, ram it well, and then we can drag it pivoting at one end, that is the center, so that you make a nice circular mold like this. So when we have a cardboard that is swept in a circular manner or along the length, to form a mold, we call it a sweep pattern. Okay, after sweep pattern, the next is segmental pattern. If you see gears like this, or now this is a small one, so you can make it a single piece pattern. Let's say you have a large gear, or let's say you have a wheel just like that with spokes. Okay, so now these spokes, you want a casting to be made of that rim. So what we do is, first, just like a sweep pattern, we make a cardboard. We sweep in small angles in a circle. So we sweep in small sectors. So this is, when you sweep in small parts, it is called a segment. So when you have small parts, so the other part is filled with sand. Okay? So wherever you do not want the molten metal to, you want a hollow, for example in a wheel. Suppose you have a wheel like this. Okay? And then you want spokes. So you want this part to be empty. So what we do is, from the center, we swept only this small part. So we have a hollow here, we have a hollow here, we have a hollow here, we have a hollow here. This part is filled with sand. So this part is filled with sand, this part is this is filled, this is filled, this is filled. So where is the hollow? This is the hollow. So what happens when you fill in the molten metal? The molten metal will fill this part, this part, this part. So when you drag in small circles or part of a circle, we call that type of pattern as segmental pattern. The next is multi-piece pattern. There are times that you cannot make a mold using only 2 flasks. We got to use more than 2 flasks, 3, 4, 5. So the lowest flask is called the drag, the topmost flask is called the coke. What about those in between? They are called cheeks. So this will be in the drag. Now let's say you have this cheek 1, cheek 2, cheek 3 and so on, and the last one will be the drag, coke. So you have the drag, coke and cheeks in between. Okay, now we shall go to the next. After multi-piece pattern, skeletal pattern. Now we are talking about a skeletal pattern. Let's say this is our casting. As you can see, it is hollow inside. Okay. So now, if we want to prepare a mold for this, we will prepare it in the drag. Okay. What about the top part? The top part, or we will prepare it like this. Now, we want to make this. So what we do is, we will prepare a mold of this sort in the drag. In the coke, it will be hollow. Since it will be hollow, this sand can collapse anytime. So what we do is, we make small pockets. Because so much of sand, the sand cannot hold into itself. So what we do is, we make small pockets or we make small cubicles of wooden strips. Inside that we fill sand. Now what happens? These small cubicles made are filled with sand, and these cubicles help in holding the sand, because here there is less sand, as you can see. So as these ribs, we can call them ribs, hold the sand in position, so that when the molten metal is poured, your sand from the mold doesn't collapse into the casting. So when we prepare such small rib cage sort of thing, we call it skeletal pattern. The next type of pattern is your cope and drag pattern. When there are large castings to be made, like that of machines, or if you see some of the vehicles on the road, they have large parts, like that of you can say road roller. Okay, so there, as humans, we cannot prepare a mold. We use machines to prepare a mold. When we use machines to prepare a mold, like you have a rammer that is huge and in the form of a machine. Okay, so you will have also the mold prepared on the machine. Those patterns that wherein to prepare the mold we use machines, it's called a cope and drag pattern. The next is your follow board pattern. Follow board pattern is similar to match plate pattern. The only difference is, in match plate you have two halves on either sides. But now let's define a follow board pattern. In a follow board pattern, you have a single piece pattern that is attached to a board or a plate on one side, so that you prepare the mold directly in the drag. So when you have a single piece pattern that is fixed to a board, it is easier to prepare the mold. So such patterns are called follow board patterns. So with that, I have told you the different types of patterns. Now we shall go to the next topic, and that is allowances. What is an allowance or tolerance? Tolerance or allowance is the minimum error that is permitted while for two mating parts. Let us take, for example, we have a bearing, a ball bearing and a shaft. Okay? So inside the bearing there is a shaft going. So now if the shaft diameter, let's say this is our bearing, a ball bearing. This is the race, and here we have the inner diameter. This is the inner diameter. Let's say we have a shaft. The shaft diameter is 25, whereas the bore diameter is 24.99. Do you think that the shaft will enter the bore? No. So we keep the shaft diameter to 25. The bore diameter should be 24.99. So it is 0.001 millimeters, which is very minimal. But it will hold the shaft tight. Let's say the example of our fan. If the diameter, if this was 25 and this was made 24.9, what would have happened? Let's take the example of our fan. It will go easily. Okay? So since it goes easily, you will say it fits. But no, what will happen is, in course of time, as it rotates, the fan will fall. Because the bearing has not held the shaft tight. So there should be some interference. Interference means, now when will there be an interference? When the diameter of the shaft is slightly bigger than the bore diameter of your bearing. If your bore diameter is 25 and if the shaft diameter is 25.01, so here you will have to press the shaft in or force the shaft in, but there is an interference. So this is called an interference fit. Let's take another example. All of you are traveling by vehicles. There is a shaft, there is a bore and piston. So now, if there is no clearance or there is interference between the bore and the piston, will your vehicle move? No. So it is desired that you have a little clearance. Clearance means a little lesser. Let's say your piston diameter, let's say this is our piston, and we have the bore of our two-wheeler. Okay, this is our two-wheeler. And as it moves, to move, it requires a little clearance. Let's say the diameter of this is 2 inches or 50.05 millimeters. Whereas the so-called bore is 50.00. So what happens? The bore diameter is small, but whereas your piston diameter, so you cannot force the piston in. So you require a little clearance. So your bore should be 50.1. There should be some clearance, not too much. So this error that is permitted, or change in dimension that is permitted either on the shaft or on the bore is called clearance, or it is called allowance or tolerance. Now this tolerance or allowance depends on the desired fit. First, I told you something about interference. Interference means where it is tight, it holds it tight. Next is your clearance fit. And the last is transition. In between the two, now let's say your bore diameter is 25, whereas your shaft also is 25. Both are the same dimension. So it is in transition. So it will go, but a slight push, slow push will be required. But whereas in interference, there is an interference, whereas the diameter is slightly less. Okay, so I hope you have understood the difference between the different types of fits. First is interference, second is transition, and the third is clearance fit. In foundry, we have 4 types of allowances. What if the casting is to be prepared? Then First, we use the pattern to prepare the mold. In this mold, we pour the molten metal. Now, on cooling, the so-called casting shrinks. Different metals shrink differently. For example, if you have aluminium, it will shrink less, whereas your cast iron or steel will shrink more. So, depending on the metal that is used, we increase the size of our pattern. Let's say we have our pattern, and let's say the length of this, or the dimension end to end was 50 millimeters. Okay, so we prepared the mold. After preparing the mold, we have poured in the molten metal. After pouring the molten metal, let's say we poured in steel. Okay, after pouring in steel, it shrunk 1 millimeter every square millimeter. Every square meter, it shrunk 1 millimeter. So, if it shrinks 1 millimeter, we have to increase, in 1 meter, we have to increase a millimeter on the pattern. So, that increase in dimension of the pattern so that the final casting is made to the required dimension is called shrinkage allowance. So, the amount of material added to the pattern so that your casting form is formed to the right dimension as desired is called shrinkage allowance. The next allowance is draft allowance. Let us say we have a very long casting. We have a long casting, square bar, something like this. This is 4 inches, this is 4 inches. Okay, the length is 12 inches, that is 30 centimeters. Now, since it is very long, it is difficult to extract it from the mold. Right? So, what we do is, we give a small taper. Here if it is 3 inches, we make it here to 3.99 inches. Very minor change. So, there is a small taper along the length. Now what happens, when you tap and try to remove the pattern, it easily comes out. So, this minor taper given longitudinally to a pattern so that it can be easily extracted from the mold cavity is called draft allowance or taper allowance. The first is shrinkage allowance. The next is draft allowance. Draft means taper. A small taper is given, but it will not have an effect on your casting. The casting will shrink to the required dimension. Okay? A minor change might occur, but it can be machined later. Okay? So, the draft allowance is the minor taper that is given longitudinally to a pattern so that it can be easily extracted from the mold. The next I shall take is wrapping allowance. In the wrapping allowance, let's say we have a very large pattern and the length also is big. Let's say the diameter or the width of it is 6 inches by 6 inches and the length is 8 inches. Okay, and there's one more pattern, 1 inch by 1 inch, and the length is 2 inches. Now, on which of the patterns do you think you will hit harder for the pattern to be removed? It is of course on the bigger one, that is 6 inches by 6 inches, and less force will be applied on the smaller pattern. Now, when you apply this force, the sand mold tries to be slightly bigger. It becomes bigger. Now, to get a compromise on this, what we do is we reduce the size of our pattern. we reduce the size of our pattern so that on hitting, the mold moves to the required dimension. So this wrapping or tapping so that our pattern mold moves to the required dimension is called wrapping allowance. So the difference between wrapping allowance and draft allowance, a taper is given. In wrapping allowance, the dimension is slightly reduced on the pattern, so it is a negative allowance. In shrinkage allowance, the dimension is increased. So here it is increased, here a small taper is given, here the dimension is decreased. Okay, the next allowance is machining allowance. Now we know a casting will not be perfect shape or the perfect dimension throughout. So we require to machine it. So wherever we require machine, let's take for example, we have our vehicles, 4-wheelers and 2-wheelers. We directly get it from the foundry and directly we assemble it. Do you think it's going to work? No. We require to machine it. Why? So that we get a perfect shape and the right dimension. So now, when we increase the size of our pattern so that we can remove that amount of material by machining. It's called machining allowance. So the increase in dimension of a pattern so that that amount of material is removed by means of machining, it's called machining allowance. So even in machining allowance, it is positive allowance. So there's an increase in dimension. Even in shrinkage allowance, it is increase in dimension. But the reason is different. In shrinkage allowance, because the metal shrinks, we increase the dimension here. But whereas in machining allowance, we increase the dimension so that that amount of material can be removed by machining. Okay, the last is camber. Camber allowance, let's say we have a thin sheet of roughly around 3 millimeters or 4 millimeters thick. We want a plate of 12 inches by 12 inches with 30 centimeters, 30 centimeters. We want the plate to be made. So now, since the thickness is small, what will happen? As the casting cools, it will tend to walk in the upward direction. So what we do is, on the pattern, we bend it in the opposite direction so that on cooling, it forms somewhat flat surface. Similarly, if you see, when we have I-beams like these, they tend to contort or twist. Now, to twist it, when you twist the pattern in the opposite direction, so that on cooling, the twisting takes place in such a way that it straightens up. It is called camber allowance. So in camber, it is neither positive nor negative. Or negative. Shrinkage allowance, positive. Draft allowance is neither positive nor negative. There is a small taper, so it won't have an effect on your casting. Next is machining allowance. You have increased the dimension. Okay. The next is wrapping allowance. You have decreased the dimension so that on wrapping, the mold becomes slightly bigger and the casting is made to the right dimension. Okay. So we have seen the 5 different types of allowances, and these allowances are used in preparing the patterns, and these patterns in turn are used in preparing the molds in which molten metal is poured and we get a casting. So I hope you have understood this part of it, that is pattern. After pattern, how you select the material for making the pattern, then the types of pattern and the allowances.